We're very pleased to have Stu Feldman, who's the VP here in New York, and he's going to talk to us about engineering innovation outside of Mountain View. Stu Feldman.
Hi. Good morning. A colleague and I, of course, are the only people standing between your break and lunch, so I realize this is a problem. Also, happy Bastille Day. First of all, there's not any question that the beating heart of Google is in Mountain View. More or less by definition in this company, that's wherever the founders are sitting that day, which usually is Mountain View. So that's life. However, the reality is that Mountain View has less than half of the engineering force in the company. And around the world, we have uniform policies, hiring standards, and job expectations and roles. So the remarkable accomplishments are global. At the moment, we have, give or take a few, 35 engineering offices total, and they're in 20 countries. So just for entertainment, I'm just putting up, these are the major offices. These don't count the places where 3 or 8 people just happen to be hanging out by accident. We're not too good at housekeeping at times, and people sort of end up places. It's weird. For my sins, I was originally hired with the title of VP East Coast. Courtesy of the most recent reorganization, I'm now responsible for the eastern parts of 4 continents. There's at least a consistency in the model, but never mind. We have lots of offices, of course, in Europe, a fair number in Asia, and then, as you may have noticed, a fair number on the West Coast, and then a lot over here. Basically, we have a truly distributed engineering model. Projects tend to be split among multiple offices. It's hard to staff everything in one place, given both history and specific skills and interests. And separately, there are advantages in some cases about having people who are either separated physically, or who speak a different language, or who have different concerns. So we take actual advantage of that. We perhaps take somewhat less advantage of the engineering around the clock model, because we tend to run that in individual offices too. People don't necessarily show up early or leave early, as you may have noticed. But we basically work real hard to see if we can really get this to work. I just want to make very clear, this is not a localization and regionalization effort. In most of the offices outside the US, there are a few people working on something that has relevance to the local culture, the local language, some local aspect for some product. Usually it's a few, like 3, 4 people, because there's some specific need. We do things like multiple language support and internationalization as a global problem, not as a set of individual problems. And I know of almost only 1 or 2 offices where the fraction of people working on efforts that are specifically aimed at the local language or market comes above 30%. And most of them was 1 or 2%. We do not currently localize for East Coast American English. So I have not had to assign any people in New York. Let me just mention a few examples of areas that are driven fundamentally outside Mountain View. The heart of the effort is elsewhere. So Google Docs, the spreadsheets, the presentation systems, the document system, all the sharing mechanisms and collaboration, those are done more or less 1 flight up from where we are right now. Local search, you go look for a shoe store near where I am. That's done also on the 10th floor here mostly. Cluster management is split between the effort you heard described this morning in Mountain View and here. And real-time search, the fact that In the good old days when Google started, we considered it quite a triumph when we updated the indices every 2 to 4 weeks. We try to be able to get some things into the search and index in minutes. Hot news and such gets popped early, and it isn't just having a little stack of 7 popular stories. This is a wide spectrum. That work happens mostly here. The snippets, when you actually search for something and you get these 3-line summaries and whatever they mystically look like, well, it turns out there's an enormous amount of cunning that goes into fitting something useful in 3 lines. That's done here. Display ads, something that no doubt all of you wish didn't happen, but people do click on the things, it seems. Otherwise, I wouldn't be standing here, and you wouldn't be eating. Happen here. The ad exchange, on which I'll spend a couple minutes, is just a fascinating, relatively new technical offering we have in advertising, done here mostly. Google Payments, checkout system, comes from here. Goggles. Other Eastern offices, book search is mostly in Cambridge. Mobile commerce is out of Waterloo, Ontario. GWT, the Google Web Toolkit, is a quite useful open source interface mechanism, UI builder. That's Atlanta. Orkut, a quite successful social network, owns more or less the Brazilian psyche, is done in Belo Horizonte now. Data liberation, transparency. I commend to you looking at google.com/transparency report if you haven't, if you're curious which countries are no longer attaching themselves to the internet, or which countries seem to be asking a remarkable number of queries of us about closing down access. It's all reported there. Malware detection is done at Montreal and Ottawa. So let me just talk just briefly, just as an example of something that sounds really mundane and yet turns out to be technically really hard. And then I'm going to hand over rapidly to a colleague to talk about work we've been doing on accessibility in order to make all of the apps genuinely accessible rather than kinda. But basically, between the time a page is selected and the time you see it, the ad slots have to be filled in. You may not think so, but we do. And various advertisers strongly think that. Well, the ad exchange basically offers a real-time opportunity. And between the time that you click the page and the time it comes up, each of the ad slots that's eligible has been auctioned off to a variety of ad network companies, each of which has had to submit a bid in 120 milliseconds or less. Basically, we run an auction instantly and render the winner before you knew any of this was happening. And we do it a lot. So the goal here is no discernible delay, because you really didn't want to wait 5 seconds for a page to come up so we could give you a really whizzy ad. At least I've not met anybody with that volunteer. And we do it with billions of ads a year. So it's just some of the challenges of doing something like that. Well, there's the scale, doing lots of queries, lots of ad placements. It's got to be done multiple places. We're talking about a volume larger than the stock exchanges, by the way, worldwide. And you have to get the data managed. There are open APIs. You have to deal with large other companies that want to bid. We come in, by the way, as neutral partners. We bid like other people, and we win or lose. Queries are, as seen by the ad system, are actually quite complex. And one of the options that comes up is that the ad exchange has been given access to sell some of the ad slots. Each page has set up carefully ad slots with funny tags in them by the publishers who are interested bluntly in getting some money for their efforts. And if they don't get paid often enough, they don't put up the page again. Or they certainly don't refresh it. So latency. You got to do this in milliseconds. Have to be fair to all the networks. a pause for music. This building, as you may or may not know, was designed for the Port Authority. The little elevator behind that screen can lift trucks. Last week we brought in a Ben & Jerry's truck, entire, rolled it off, and just for 3 hours the people were selling Ben & Jerry's for free. And we just bought out the truck, of course. And we just lifted it and off we went. We don't worry about floor loadings much in this building, as you may have noticed. And let me just talk while the guys bang. There's no question that it's an elevator. Okay, you have lots of policy issues. People don't want ads from their competitors sometimes. They don't want ads for various products they view as unseemly and so forth. So the publishers have their rules, the advertisers have their rules, and then they all have opinions about what things are worth. All this gets enforced, and it happens in milliseconds. Ad matching is a complex issue because of all of these restrictions, all of these concerns. They all have to be encoded. They all have to run real fast and in enormous parallel. So publishers speak to the ad exchange and say, this is a page I'm willing to have you sell. The ad exchange talks to all these. The term of art is an ad network. This is. We don't deal with random companies. We deal with companies that we can reasonably trust and enforce against, because we're counting on there being no malware. We're counting on there being no garbage. And yes, we have enormous system investments that go and check it anyway. Except we can't quite do full malware or porn detection in 5 milliseconds yet. So we do post checks there. So I will stop in a moment, but let me just say it's not so trivial. If you think hard, what the structure of these auctions should be is not self-evident. We're basically running a Victory auction with some slight modifications, carefully thought through. What are you optimizing? What behaviors are you trying to make incentive compatible? Turned out to be rather interesting. And then there's some rather subtle questions that come up in how you manage decisions about who you're going to call out to. You can't actually broadcast the entire universe on every ad. You have to have a reasonable probability of what it's going to be. There's a fair amount of a priori analysis to decide who's going to get. It has to be randomly fair enough. This is a bulk business. So there are really hard problems buried under, we're going to go sell a few ads, please. So those slides were stolen from a talk given at WWW last year. There's, of course, a lot more work since. I can point you to the paper, and most of the interesting work happened for this was done about 150 feet that way. So let me just switch entirely to talk about just accessibility. Basically, the goal is to make the Google applications really accessible right now to the visually impaired. Obviously, there are other challenges that also will be addressed, but that is the sort of the high runner of difficulties at this moment. Basically, to be blunt, we were shamed into this partly. Some people pointed out we were doing a surprisingly poor job when we thought we were doing an okay job in this area. And we just decided this had to become a high priority rather than we'll get to it sometime. And we also decided that we weren't just going to do a surface quick hack to change a few buttons and get a few things working in the readers temporarily. And so it's a deep set of fixes in the underlying interaction models and code in order to get this to work. The rest of the presentation will be by Jeff Harris, Princeton 08 economics and computer science. Jeff.
I'm not on. I think I'm on now. Perfect. All right. So And the way I want to do that is I want to talk to you about the evolution of Google Docs a little bit. So Google Docs is a company we started acquiring in 2005, a company called Upstartle, and they built a product that we call Writely. And this is actually Writely right in front of you. So it looks like a document. It's very, very standard. I'm going to talk a little bit about how it works in 1 second. And the big evolution, the big breakthrough in Google Docs happened about a year ago when we released a new version of Google Docs that mostly behind the scenes, and this is what the new version looks like. So in both windows, I have Alice in Wonderland open, and they look pretty similar, but there's actually very, very fundamental architectural changes. And I want to talk about this a little bit, and then I'm going to talk about how those changes influence accessibility in a product like Google Docs. So the way Writely works, this is the old version of Google Docs, is it uses a browser component called Content Editable. And what that means is you take an element, an HTML element, and you tell the browser to make it editable. And I'll show you what that looks like. So I can actually just inspect the document itself. And you can see here, content editable equals true. And that's the key line. And then I can actually open the doc, and this is the HTML of the document. So this is chapter 1. This is a paragraph tag. So what's happening here? Well, I am telling the browser to make this element editable. And what that means is that when a user clicks on that editable element, they get a cursor. The browser takes care of generating a cursor. When the user starts to type, so hello world, the browser notices that the user is typing, figures out the characters that correspond to what they're typing, puts those characters into the HTML of the page itself, and then renders the page. And that's what browsers do. They take the HTML of the page and they render it. So that's actually really, really easy from building an application perspective. All we did is say, make this element editable, and the browser handled all the rest. We had to take care of some things like saving. We had to detect when things had changed, send them to the server, broadcast those changes to other collaborators. But that was the core of the technical challenge in the old Google Docs. Now, the new Google Docs actually works very differently. So I want to point out a couple things, just high level. One thing is this image here. So this is, see the same image here and notice how it's different. Now, what's happened is this is a fixed position image. And if I take it and drop it up there, you can see something kind of interesting happen. So if I type, you're going to see that the text is actually wrapping around the image itself. And that's a feature that isn't possible to do in a browser. Because what this feature is all about is I am positioning an image absolutely on the page, and I have to take care of flowing text around it. Now, browsers don't have the concept of absolute positioning. They are stretchy. The browser is designed to take HTML and make it fit in whatever size your screen is. So this is a word processing concept that is not representable in the old version of Google Docs. So how do we do this? Well, the way the new version of Google Docs works is we built a JavaScript editing surface and a layout engine. So what happens when I type the letter A is we get a key event that says the letter A is pressed. Nothing visible happens to respond to that key event just yet. The next thing is we say, okay, the user typed the letter A. We know the size and the style of their cursor. So we are going to take that letter A, render it in that size and style, draw it off screen. We're going to measure the width and the height of that character, and then we're going to put it at the right cursor position, at the X and Y position that their cursor is. We're going to advance the cursor, which is actually, it's not a browser cursor like in the old application. This is just a div that we are drawing on the screen and we are making flash every 1 second. We're going to advance the cursor by the width of that character. If they're typing at the end of a line, we're going to wrap words around that line and reflow them down the paragraph, cascading down the page. And that changed to basically say, instead of letting the browser handle all of the text processing, we are going to do everything ourselves. That ends up being a very, very powerful thing. And I'll give you just a few examples of why that's powerful. The first is what's happening here. So this document is paginated, which you've seen before. It doesn't seem that exciting. You can't do that with the browser's text engine because the browser doesn't have the concept of a paginated document. So that's impossible. Other things. So let me make a list. So 1, 2, 3, and then I'm going to press enter in the list and say hello. Now this also doesn't seem that exciting, but what I'm going to do here is I'm going to press enter again, and you're going to notice that this number gets updated. So hello there. So this is a discontinuous list. That's another simple word processing concept that you can't represent in the browser's text area. So we think that this approach of basically handling all text rendering, text input processing is a huge technological change, a really, really important thing that Google Docs has done. And it gives us the advantage of being complete control. Any feature that exists in a desktop editor, we can do. The disadvantages, the first one is performance. JavaScript is getting way, way faster, but it's always going to be a challenge to make it really, really fast. So the new version of Google Docs, getting it to perform, doesn't come for free, where it did come for free before. A second big challenge, though, is accessibility. So in the old version of Google Docs, I have the Chromebox extension running. Let me see if this works. So I'm going to start typing. Oh, it's not on. Let me actually just talk about this in the new version in 1 second. So the way accessibility usually works is you type in a text area and the browser knows that you're typing, and the browser can say the characters that you're typing, and it can say when you move down a line, it can read that line, and it can do all that stuff itself. That's how a traditional text editor would work online. Unfortunately, that doesn't work with Google Docs, because remember that this cursor up here isn't a cursor. It's a floating div that we're drawing on the screen. So when I press the down arrow and Google Docs moves that cursor to the other line, the browser has no idea what happened. As far as it's concerned, an HTML page has just done some JavaScript and changed the way it laid itself out a little bit, but the browser doesn't know that this is a text area. It's just a page that's regenerating itself dynamically, which makes accessibility hard because we don't get anything for free. The browser doesn't do anything. So that's kind of a problem for us, because if you look at Google's mission statement, what we say is we want to make information universally available. We want to make it accessible to everyone. And we can't do that for free in the browser. So what we've ended up doing is we've built a couple technologies. The first one is a browser extension that we're calling Chromevox. And this is an extension that's designed to make the web readable. And it ends up that this is a really big deal. And it's a big deal because existing accessible solutions like JAWS end up being expensive. They end up being very platform-specific, very application-specific. So what Chromevox is, and I'll give you an example, a demo of it in a sec, is it's just an extension that's for free that can be installed in any version of Google Docs. So any visually impaired person can install Chromevox. It doesn't cost them anything, and it will just work. And I think that's really important. But from an application developer standpoint, it's also important because we now have the control to say exactly what the experience should be. So in Google Docs, we have designed an accessible experience that takes advantage of Chromevox. So I'll turn on the volume. So what's going to happen, I'm going to move around, and if I go up a line, I'll actually put this close to the mic.
Down the rabbit hole.
So I'm moving the cursor. What's happening is Google Docs is saying, okay, he moved the cursor down one line. We're not going to just read the word. We're going to read that whole line. So
Alice was beginning to get very tired of sitting by her sister on the bank and having no interest.
So that ends up being a little exciting, but not that great. And then we can do more advanced things like Alice. Sorry.
Down the rabbit hole.
So I can select things. I can say rabbit. As I'm moving, I can say all the letters. And again, the story of the accessibility in Google Docs is one of complete control. So we specify every single user action. What is the verbal thing that should happen as part of that action? And this is the beginning. We're actually going to launch a fully accessible version of Google Docs in about a month.
Chapter highlighted.
And it seems basic, but having this kind of accessible control means that we can actually make this application, the experience, really, really great. So what I've just showed you right now is basic text editing, not the most exciting thing, but I want to also show you some of the direction things that we're thinking about. One really important thing about accessibility is that it shouldn't just benefit people that are visually impaired. So one of the things that we're looking at right now is something that we call the Omnibox. And what that means is that you can do your editing, and then you can trigger with a quick shortcut, and you notice I can jump into that box up there. It probably won't stay there. But what I can do is I can type commands. So without ever needing to use the mouse, I can just jump up here and type, strike through, and I can cross out that text. And that's a really nice editing experience because it means that accessible people have access to every command without even needing to figure out the navigation structure of our menus. But it's the beginning. So one of the things that's awesome about Google Docs is that it's online. So what we can start to do is we can start to say things like, well, if a user is in a paragraph and they type the letter B, maybe they mean to bold. Maybe that's the most common thing, and we can get statistics on that, and we can say, as users are typing B in this context, it probably means bold. Or maybe John, every time he's in a list, the first thing he does is change it to Roman numerals. And if he opens up this box and types R, we will detect that he's changed it to Roman numerals. And we can start crowdsourcing this whole solution of exactly what the right accessible experience should be, because as people are typing, we're figuring out the actions that they're trying to do, and we can start suggesting that action really, really optimistically. So that's kind of the direction we're going. I think we see accessibility as a long-term differentiator for Google Docs. So we started a little behind because it was really challenging to support it in the first place. But now that we have this free Chromebox extension in place and basically the infrastructure to come up with spoken commands that correspond to every user visible action, we think we can get an amazing verbal experience, and then hopefully an experience that's really optimized both for accessible users and for power users, for people that just want to edit really, really quickly. So that's all I wanted to show you today. I will be sticking around if you guys have any questions. Thank you.